Now let's continue on with our two-sample t-test, and now let's look at a confidence interval for a two-sample t. So let's look at the same example from the last slide where we're looking at the lean versus obese people. And this time I want to get a 90% confidence interval for the data on the standing and walking group. So we'll go back to our StatCrunch. Okay, we're going to look at the standing and walking group again. We'll go to our stat, our statistic, our two sample, and our with data again. Our lean group standing and walking is our first column. Our obese group standing and walking is our next column. This time I want to do a confidence interval, and I'm looking at a 90%. So I'm going to change that to a 0.9, meaning 90% of the time our differences between the two will land in that interval. So we'll click calculate. We get a lower limit of 83. We get an upper limit of 221.9. What this tells us is the difference, where the mean differences lie. So if I take the mean of the first group minus the mean of the second group, my difference would lie somewhere between 83 and 221.9, 90% of the time. So that tells me that there is a positive difference, meaning that the first group minus the second group is going to give me a positive difference. So my lean group, according to my confidence interval, is probably bigger than my obese group because I do have a positive difference 90% of the time, somewhere between 83 minutes and 221 minutes. What I would want to do then is run a two-sample t-test testing that the lean group is actually greater than the obese group and see if that is the case, if the lean group actually spends more minutes than the obese group does.